Hi, this is Shannon Seaver, and today we're looking at the third part of rational numbers. On our agenda for today is to multiply and divide rational numbers, add and subtract rational numbers, and solve problems involving rational numbers. So if it has to do with fractions, it's all things fractions today. So first of all, I want to talk about how to multiply a rational number. With rational numbers, we're really going to multiply the numerators straight across and then the denominator straight across. So in this case, 3 times 5 over 8 times 11 is the same thing as saying 15 over 88. Another way to do this would be to actually reduce first, then multiply. So we're going to look across in the diagonals. Notice that 2 is a factor of 4, so I can cancel out 2. And then 4 divided by 2 is 2. I can do the same with the 3's. 3 goes into 9 3 times, and I can cancel out the 3. So now I have negative, and now I can call these 1s. So 1 over 1 times negative 3 over 2. Now remember, a negative times a negative is a positive. So we have now 3 over 2 as our answer. All right, so the next one I want to show you is a mixed number. When we have mixed numbers, we need to convert them to improper fractions first. So remember, for this, I'm going to take 3 times 3 plus 2 over 3. Okay, and I'm going to multiply that by 4 times 1 plus 1 over 4. So 3 times 3 is 9, plus 2 is 11 thirds, times 4 times 1 is 4, plus 1 is 5. It's 5 fourths. If we multiply straight across, we'll have 55 over 12. I'm going to pause the video, and I want you to try it on your own and then check back. So these are the 3 answers I got on this one. Note that I did have to reduce this one further because 6 over 4 could be divided by 2 on both top and bottom for 3 over 2. Dividing rational numbers. Remember that when we divide a rational number, we are going to actually turn it into a multiplication number by taking the reciprocal of the second term. So I can rewrite part A as 4 over 5 times 10 over 1. Now I can reduce it before I multiply because 5 goes into 10. I'm going to take 5 and make that a 1. 10 becomes a 2 and multiply straight across. So 4 times 2 is 8. 1 times 1 is 1. It's the same thing as saying 8. Okay, on the second one, we're going to do the same thing. I'm going to still start off with 3/5, but I'm going to make the reciprocal of 7/11. So it'll be 11 over 7. Okay, so this is a negative times a positive, so you know the outcome is going to be negative. We're going to take 3 times 11, which is 33, and 5 times 7 is 35. So my answer on this one is negative 33 over 35. Now we have 2 mixed numbers, and remember, we want to make them improper first. So 4 times 4 plus 3 over 4 divided by 2 times 1 plus 1 over 2. So 12, or actually 4 times 4 is 16 plus 3 is 19 over 4 divided by 3 over 2. Now remember, when we're dividing, we're going to take this and make it a reciprocal. So now it's 19 over 4 times 2 over 3. And I can reduce this 2 because it goes into 4 one time to itself, 2 times into 4. So 19 times 1 is 19, and 2 times 3 is 6. So this is my answer for C. So now I want you to pause the video and try it yourself. Here are the 3 answers that I got. Adding and subtracting rational numbers are actually sometimes thought of to be more difficult than multiplying and dividing. Part of the reason is because you have to have like denominators in order to add or subtract. So in our first two examples here, we have denominators of 7. So I can go ahead and add across the top, and the denominators will stay the same on the bottom. So this would be 3 plus 2, that's 5, 5/7. On this one, because the denominators are the same, once again, it'll still say 12ths, but 11 minus 5 is 6. Now, however, I can reduce this. So 6, both of them can be divisible by 6. So now I have 1/2. That's the answer in that one. On unlike denominators, I need to find a common denominator first. On this case, 5 and 4, you can multiply those two together to find a common denominator. So I'm going to multiply both top and bottom by 5 on this one, by 4 on this one. So this would be 4/20 plus 15/20. If I add those together, I will get 19/20. Okay. We need to find a common denominator for 15 and 24. So to do that, one thing I could do is multiply top and bottom by 24 on both of these, and then top and bottom by 15. Notice that it's just the opposite of what it was to start with on this. So when I do that, I have 24 over 360 minus 7 times 15. That would be the same thing as saying 70 plus 35, which is 105, or 360. Sorry, the little scribble there. Alright, so now let's finish this. So 105 minus 24 is 81. This will be negative because this one's a larger absolute value. So negative 81 over 360. Now, I know for a fact that 9 goes into both of these, so I can reduce it. So this will be a negative 9 over 40. And I believe that is as far as we can go. So it'll be negative 9/40. Pause the video, try this one. So my results in the first one was 11/12. The second one is 17/60. Now this is a common problem that you have to do when you're a cook, and how to change the amount that you're using in a recipe. So for instance, a chocolate chip cookie recipe for 5 dozen cookies requires 3/4 cup of sugar. If you want to make 8 dozen cookies, how much sugar is needed? So first of all, you're going to want the desired serving size over the recipe serving size. So in this case, we want 8 dozen, so 8's going to be on the top. The recipe size is 5, so that'll be on the bottom, and I'm going to multiply that by 3/4 cup. So when I multiply this out, I'm going to have, first of all, I'm going to reduce this because 4 goes into 8, so it'll be 2 times 3 is 6, or 5 times 1 is 5. So we will need 6/5 of a cup. Now you take your time and try this and see if you get the same answer I do. Okay, note that we have we want 7 dozen cookies, and we have a recipe for 5 dozen cookies. We have 2 eggs per 5 dozen. So one of the things you need to know is that when we're taking a fraction and multiplying by a whole number, it's the same as saying 2 over 1 in fraction form. So then I multiply straight across. So that'll be 14 over 5. So in this case, exactly how many eggs are needed? Well, we can't have 14/5 of an egg. So that's like saying 2 and 4/5, right? So really, the realistic thing that we're going to do is actually round up. So we would actually get like 3 eggs for this recipe. That is the end of this video.